Okay. So our next topic is cyclotron. It is a particle accelerator. So we need to accelerate these elementary particles to perform certain experiments or to verify certain interactions in particle physics. Okay, so this cyclotron is a device that works in non-relativistic element. So the particle velocities are less than c by 2 at least. They are not comparable to velocity of light. So the cyclotron works with constant frequency. It is a constant frequency non-relativistic particle accelerator. Right. So this cyclotron is a constant frequency non-relativistic particle accelerator. So here we have two metal drums cut into D shape. So it consists of two metal drums cut into D shape. So they look like this. Okay, and at the center of it, this whatever particle generator will be there. It could be any radioactive element. So those charged particles, I mean it is used to accelerate charged particles using electric and magnetic fields. Okay, so here it is connected to a radio frequency electric field. So it is, which will be changing its sign alternatively, plus to minus and minus to plus alternatively, depending on the frequency of this source. Next one, magnetic field is applied perpendicular to this. So magnetic field is applied perpendicular to this D drums, D-shaped drums. So when you apply magnetic field on a charged particle, it executes circular motion. So this BVQ is equal to mv square by r. This is the centripetal force experienced by the charged particle when placed in a magnetic field. So first of all, this particle must be moving. So it should have certain velocity. Then any moving charge in the presence of magnetic field will execute, in presence of perpendicular magnetic field will execute circular motion. Okay. So the initial velocity for this is produced by this electric field. So if the incoming particles are positive and let's say this drum is negative, it will be accelerated towards this. That is the initial push produced by the electric field. So then this particle will move in a circular path with constant speed. So here V is constant for a particular speed and for a particular magnetic field. So here I am fixing the magnetic field strength. So once it is accelerated and enters into this drum, electric field will not affect it further. So the electric field applies only in between these two drums. So initial acceleration is produced by electric field. So once the particle enters the drum, its velocity is fixed. I mean, there is no further force of attraction or any force acting on it. So it moves with constant speed or velocity. So in the presence of perpendicular magnetic field, the particle executes circular motion. And once it reaches the boundaries of the drum, again it will get accelerated by the electric field. So instead of executing a constant circular motion, because of this additional acceleration, this path takes a higher orbit. So if there is only magnetic field, the particle would have taken only a circular path with constant radius. But there is an additional electric field which adds an extra acceleration, so it pulls the particles a little more in between these two drums. So further, it takes a constant higher radius path, and it continues. The process continues till you reach the boundaries of the cyclotron. So here, I mean, circular motion implies the particle is under a centripetal force. So when there is a force, there must be acceleration. But here the magnitude of speed is not changing, but direction is changing. So because of the change in direction, I mean, when the particle is moving in a circular path, there will be acceleration with constant speed. Speed remains constant, I mean that number remains constant, but direction is changing from point to point. So that is why it is called acceleration, centripetal acceleration, centripetal force. But the magnitude of speed remains constant. So we cannot expect any higher speeds if there exists only magnetic field. So just because of this additional electric field, this process continues till the particle reaches the boundaries of that D-shaped drums. So the final velocity or final acceleration obtained by the particle is a combination of both electric field and magnetic field effects. Okay, so here what can we write from here? BVQ is mv square by r. So if we cancel this, so velocity of the particle is what? VQ r by. So this is the velocity of the particle. And time of travel in single drum is half of the omega is what? Omega is 2 pi by t. T is equal to 2 pi by omega. What am I doing here? I am considering half of it. For a single drum, I am considering half of it. So half of 2 pi by omega. So it is pi by omega. omega is v by r, so it is pi r by v. So that is the time period of the particle for that particular velocity. And frequency is 1 by time period. So v is what? bqr by m. So that is the frequency of oscillations. I mean, if you take double to that, so frequency of AC field must be twice of this. Twice a half hour. So I mean, this should change sign at this point of time. Half of it. So frequency of AC must be switching alternatively during this interval. Okay. So now I'm considering the extremes of this story. Eta max is equal to half mv square max. So that is the maximum kinetic energy that can be imparted to the particle. Then Eta max is half mv square. So I can write it as NQV. N is the number of turns, Q is the charge, V is the electric potential applied. So the potential energy supplied by the electric field to the particle is what? Potential energy is obtained by multiplying voltage with the charge. So in electricity we have what? Electric field or electromotive force, which is the force experienced by unit charge. The same way electric potential is what? Q. Energy supplied to each charge. Electric potential is the energy supplied to each charge or work done on each charge. Work done will be converted to its potential energy. So electric potential is the energy supplied to each charge. Okay. So potential energy is what? Voltage multiplied by charge. Okay. So this is the energy supplied to the charge Q, and this energy is being supplied n number of times. N is the number of loops. So n times QV is the electrical energy supplied to the charged particle, and this one in terms of magnetic energy, this can be written as what? Half mv square, half m BQR by m whole square, v square. So I call V max as VQ capital R by m. R is the radius of the drum. So small r is the radius of the path and capital R is the radius of the drum. So that is the maximum velocity that can be applied. So from here, what is the ultimate requirement? So from this expression or from these two equations, what is R? R is square root of that. So here one m will get cancelled. So 2n qv whole square root by bq. So that is the maximum radius or size of the drum. So the maximum velocity is controlled by what? Your applied electric potential and magnetic field. So where is that acceleration part taking place? I mean, who is the controller of acceleration? Magnetic field ensures only the constant velocity for the particle. So if you have only just electric field, the structure of this accelerator must be linear. Electric field applies along the direction of motion of the particle. Electric field produces acceleration along the direction of motion of particle. So if you want to have more and more acceleration, you need to create a very long track, which may not be possible always. So we are just using magnetic field to turn the particle back into the same track. So the main acceleration is produced by electric field, not by magnetic field. Magnetic field just controls the track of the particle and it maintains constant velocity. Okay. So whatever frequency you are using, now this frequency is a function of magnetic field. You see that? So at any point of time, whatever velocity produced or taken up by this magnetic field should be matching with the frequency of the electric generator. So once that electric field frequency matches with the frequency of the motion, the particle will continue to move in the circular path. So now the maximum velocity is controlled by just by this potential, electric potential. So how many number of times or number of turns this particle is revolving in the path multiplied by the charge and the applied potential. Okay. So after a certain limit, so as long as this magnetic field, charge and mass are constant, this frequency remains constant. So the frequency of this electric field remains constant as long as you keep the magnetic field constant, charged particle is already constant, mass is also constant. But when you reach the relativistic limit, so this is non-relativistic. mechanism. So when you reach the relativistic limit, what happens? This m is now replaced by gamma m naught. Gamma is what? So it is m naught by square root of 1 minus v square by c square. So in that case, frequency also carries a functional dependency on velocity. So we have to alter the frequency of the electric field in order to maintain the particle within the system. Otherwise, it will escape or it may collapse into the center of the cyclotron. So when the velocities reach or approach the relativistic limit, we must ensure a correction to the frequency, relativistic correction to the frequency, because that frequency depends on mass. And when velocities approach relativistic limit, this mass varies. So that is the principle in Sinchro cyclotron, where this frequency of electric field is also tuned in accordance with the relativistic mass corrections. Okay? Rest of the details we'll see in the next session. Right, so our ultimate aim here is to obtain some maximum velocity. So what are the control parameters for that? One, strength of the electric field. So if you rise the electric field strength, what happens? At every cycle, a particle gets accelerated more and more. So if you rise the strength of electric field, the particle will take longer orbit. And ultimately, for this structure, the control parameter is the radius of the drum. So once it reaches the boundary, the particle will exit. So radius is one control parameter and magnetic field is another control parameter. What does it do? Magnetic field. Is it a control parameter? See this half ma square, the velocity is now proportional to strength of the magnetic field as well as the radius of the drum. So for a fixed value of radius of the drum, if you rise the magnetic field, velocity increases. How come? How is it possible? So if you rise the magnetic field, what is happening? This ratio, for a fixed value of magnetic field, the ratio of V by R is a constant. You understand that? For a fixed value of magnetic field, the ratio of V by R is a constant. That means what? You can rise the velocity, at the same time rise the radius, so that the ratio remains fixed. In other words, if I rise the magnetic field, I can rise the velocity and keep the particle in the same radius orbit. If I rise the magnetic field, I can rise the velocity and keep the radius of the orbit fixed. So that means what? For the same structure, if I rise the magnetic field, I can rise the kinetic energy. For the same magnetic field, if I rise the drum size, I can rise the maximum velocity, and if I rise the potential, I can rise the maximum velocity. So these are the three possibilities where you can control the maximum velocity obtained by the charged particle. So after certain limit, once you reach the relativistic limit, you have to make corrections for frequency of the electric field. So with that correction, you can obtain velocities beyond that relativistic limit. Okay. So with that, I'm closing the session. Yeah.